In this video, we're going to cover the next section, 1.2, graphs of equations. This is part of the first unit. There's quite a bit of stuff to copy, so just bear with me. Go ahead and copy this down first. If you need to pause the video, go ahead. I'm going to move it up just a little bit for the rest of the definitions. Okay, so we have three definitions here. We have definition one, we have the equation in two variables, which is a relationship between two quantities. So usually x and y. For example, y equals 3x minus 4. Okay. Definition two, we've kind of seen this one already. We have an ordered pair A, B, and this is a solution or solution point if when plugged into the equation results in a true statement. In other words, if I take this point here, so whatever this value is, if I take it and I plug it into my x and y here, and it comes out the same on both sides, then it would be considered a solution, okay? The last one is the graph of an equation, and this is just a set of all points that are solutions of that equation. So if this point is a solution to this, well, that's just one point. What makes the rest of the line or curve or whatever? So all those points put together, that makes the graph. Okay, so we're going to go ahead and start right with an example. This is example one. It says determine if letter A, -3, 2, and letter B, 2, 13, lie on the graph of y equals 10x minus 7. So all we're going to do for this problem is we're just going to take these numbers, plug them into here, and see if it's a true statement. Okay, so let's go ahead and start with that. I'm going to go ahead and move this down just a little bit. Hopefully the focus is better in this video. I did mess with the settings a bit. So for letter A, okay, we're going to be testing, we're checking -3 and 2, -3, 2. Okay, so I am going to color code just a little bit. My x here would be, in this case, the -3, and my y is going to be the 2. So I'm going to make sure that I plug those numbers into the corresponding spot. Okay, so for y we have 2, so 2 is equal to 10 times x, but in this case, x is equal to -3, okay, minus 7. So we're going to go ahead and work that out using PEMDAS. So let's go ahead and multiply. So we have 10 times, move this up a bit, 10 times -3. This right here is going to give us -30. Okay, bring down that 7, bring down the 2. So we have 2 is equal to -30 minus 7 is -37. So this one is not a true statement, which means that this point, this ordered pair, is not a solution. So -3, 2 is not a solution. So it would not be on this line. Okay, right next to it, we're going to check letter B. So letter B is 2, 13. And we're going to do the same thing we did. So now our x is 2 and our y is 13. Okay, so we start off with the y value. We have 13 is equal to, is equal to 10 times 2 in this case, because our x value is 2, minus 7. Okay, so same as before, we're going to multiply first. 10 times 2 is 20. Bring everything else down. So bring down that 13, bring down the 7, and that gives us, let's see, 13 is equal to 20 minus 7 is 13. So this one is worked out nicely for us, which means that 213 is a solution. And this is how you would check if an ordered pair is part of the graph using the equation. Okay, we're going to go ahead and move on to the next parts. So you can, if you have room, you can keep going. I'm going to go ahead and, I already kind of pre-wrote this out. So go ahead and take a moment to copy this at the top. We're going to be sketching the graph of an equation. Ignore this, by the way. I could not find my whiteout, so just pretend that's not there. We have example number 2, and it's this equation right here. So this is what we're looking at, okay? And I want to sketch this graph using a table, okay? So The first thing I'm going to do, it says here, step 1 is to rewrite this. How am I going to rewrite it? Well, I'm going to rewrite it in the way that I usually see linear equations as y equals. So we're going to rewrite this 2x plus y equals 3 as a y equals mx plus b form. Okay, so to do that, I'm going to take this 2x and subtract it from both sides. Okay, and that leaves me with y equals. I'm going to go ahead and put the x first, so negative 2x, and I still have that 3 plus 3. So it looks like this is my y equals mx plus b that I was looking for. And this should look familiar to you, okay? So once you have this, we're going to go ahead and make a table using this equation. So right here, I'm going to plug in what I just found, and let me kind of show you. So I'm going to take this right here now and put it over here, okay? And I'm just going to make a table. So all my x values, this is an x, by the way. Again, I'm using pen, so you should probably use pencil. So all my x values here, I went ahead and just pre-chose these. I chose some negative numbers going into some positive numbers just so I could kind of see a better shape of what the graph is going to look like, okay? What I'm going to do is I'm just going to take this number and plug it in. So it will look like this. So y equals, okay, negative 2 parentheses, and instead of the x, I'm going to take that negative 3 and plug it in. So negative 3 plus 3. And I'm going to do this in my head. If you need additional work for this, go ahead and do that on the side. But all you're doing is this part right here. You are calculating this part right here. Okay, so that would be, see, negative 2 times negative 3 is positive 6, and 6 plus 3 is 9. So over here, I would have negative 3, because that's the x, comma, 9. Okay, same thing on the next one. I'm just going to go ahead and write this part because of the room. So we have negative 2 times negative 2 plus 3. And that looks like it's going to be 4 plus 3 is 7. So negative 2 comma 7. Next one, negative 2 times negative 1 plus 3. That's going to be positive 2 plus 3 is 5. So I have negative 1 comma 5. And you should be kind of seeing a pattern here. Okay, negative 2 times 0 plus 3. 0 plus 3 is 3, so 0 comma 3. And last but not least, negative 2 times 1 plus 3. That's negative 2 plus 3 is 1. So this would be 1 comma 1. Okay, so now that we have these values, we're going to use this column here to sketch a graph. So let me move this down just a little bit. I want to show you the next part just yet. And I'm going to do a graph. So this is going to be a sketch. So I'm going to kind of estimate some of the points. It looks like I have to go all the way up to 9 on my y-axis. So I'll make sure just keep that in mind. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll do up to 10. And down here, I don't really have any negative numbers, so I'm just going to do a few. Okay. Looks like I'm going from negative 3 through 1. So I can make these pretty spaced out. Negative 3. Okay. 1, 2, 3. So notice that I do try to keep my intervals pretty similar. Again, if it's not perfect, that's fine. Do the best that you can. Okay. So first one is negative 3, 9. That's going to be about here. We're just plotting these points now. Then we have negative 2, 7. So 10, 9, 8, 7. So about right there. Negative 1, 5. So 2 more down, 6, 5 right there. 0, 3. 0, 1, 2, 3. Okay. And 1, 1. So the general shape of our line looks kind of like this. Okay. And this is a pretty decent sketch of our equation, given some values. Okay, we're going to do another example. This one's going to look a little bit different. So go ahead and copy this one now. Okay, in this one, we don't have to solve for y. It's already solved for us, so we can go right into the table. Okay, just like the one before, I'm going to choose some x values that are negative. So I'm going to start with -2, -1, 0, 1, and 2. Okay, now I'm using these kind of on purpose. You'll see why in the next example. So we're going to plug these values now into our equation, which is already solved for us. Okay, so there it is. So now I'm going to have -2 squared minus 1, -1 squared minus 1, 0 squared minus 1 squared minus 1, and 2 squared minus 1. And I'm just going to calculate what all these are. So remember that when you square something, everything does come out positive. This is probably not the best pen. Seems like it's kind of leaking. Sorry about that. But yeah, everything is positive. So -2 squared is going to be +4. 4 minus 1 is 3. Let's go ahead and keep the color. So -2 comma 3. Okay. -1 squared is 1. 1 minus 1 is 0. So we have -1, 0. Okay. 0 squared is just 0. And then 0 minus 1 is -1. So 0, -1. Just in case you didn't catch it yet, the number that I'm getting from here is the second value here. It's the y value. Okay. 1 squared is 1. 1 minus 1 is 0. So this is 1 comma 0. Okay. And finally, 2 squared is 4. 4 minus 1 is 3. So 2 comma 3. Okay. Right here, right next to it, I'm going to go ahead and sketch a graph. Okay. So this one I have all the way up to 3. So I'm going to go ahead and just do 5. 1, 2, 4, 5. 1, 2, 3, 4, 5, both sides. And on this side, we'll do 3 on each. 1, 2, 3. 1, 2, 3. I typically like to go a little bit more than whatever I have here. Okay, so we have -2, 3. So go ahead and just plot these points. That's what I'm doing right here. So -2, 1, 2, 3, 3, right there. -1, 0, 0, -1, 1, 0, and 2, 3. So it looks like this one is kind of curvish. That's probably not a word, but and it should look familiar to you. Okay, this is actually a parabola. The reason we are putting arrows, and I did want to make note of that because I've noticed a lot of students tend to do this. This is an equation. We are given y equals something. So if that means that there's going to, I could keep going on this table up and I could keep going down. That means that this graph is going to continue. It's not just going to stop at the values that I decided to use. So please make sure that you do put the arrows. Don't just cap it off here and say, oh, that's the graph. No, the graph is going to continue in this case. There are cases where we're going to have some that do stop in certain places, and we will get to those when we get to those. But for now, this one continues, okay? Because x squared is a parabola. Moving on. Okay, we're going to go ahead and look at example 4 now. So this one says plot and classify the type of graph for -2 to -1, -1, 1, -1, and 2, 2. So this one, instead of giving us a table, they gave us points. So you could make a table and do it that way, or you can just go straight into the graph. I'm going to go ahead and just draw the graph, and we'll go from there. Okay, so let's see what this graph looks like. It looks like the numbers are kind of small, so I'm going to go ahead and just do 3 for each side. Okay, we have -2, 2, so -2, 2 here somewhere. -1, -1. So I'm not going to put the number there because that was kind of close to the line. I'm sorry, 1, -1. So that one's right here. And 2, 2. So I can put that one. Okay, so it kind of looks like the graph that I had on the other side where I had something like this. Okay. But the problem with this example is that we are not given an equation, okay? So since there is no equation for this one, yes, this is a possible graph, but I can't say for sure that it's going to be a parabola. It's going to look like this. So this is one possibility, okay? Another possibility that we might have, and this one I'm just going to kind of sketch it. Let's see, I had a point. I'm just going to do the two. I had a point here. I had a point here, here, and here. So another possibility that I might have with this graph is that it actually keeps on going this way, right? It could keep going that way. I'm putting the arrows because we don't know what this is. So this could be a function, it could be an actual graph, or it could just be a list of ordered pairs, okay? So this is another possibility. So this is a second possibility. Can we think of another one? Well, I can think of one. So again, I'm just going to kind of put the points where they're kind of are at, maybe something like that, okay? And I could even say that this graph is something like, I don't know, something like this, which isn't even a function, but it's a possibility of what these points might be part of, okay? So the idea for this one is that this method right here where you're plotting the points, okay, then by the way, this is called the plot pointing method. I think I wrote that on the side somewhere, a different example. So the plot pointing method isn't always going to work. Isn't always, I'm going to put this more officially, a great indicator, okay, for what a graph looks like. Okay, because of this case where you don't know what the equation is, so therefore you don't really know the type of graph it is. And so because of that, this is kind of the reason why we do teach you about parent functions. I'm sure you've heard of those words before. If you know what type of function your equation is, then that usually helps figure out, okay, well, it's going to look like this one, or it's going to look like this one, or something else completely different. Okay, so just keep that in mind. Okay, all right, here we go. A little bit more to copy. Before I give you the next part, I do want you to write this remark down. We kind of covered a little bit of linear equation. This is the form that we saw, y equals mx plus b. And quadratic equations, these are the form ax squared plus bx plus c. The one that we saw for quadratic was just an x squared and a c value. So it was just kind of like these two. But we will see these a little bit more later on this year. Okay, so just go ahead and write these down. These are the general forms of those two types of equations. And if you want to put here on the side, they look like that. So that one's like this, and this one looks like that. Okay? All right, next part of this is intercepts of a graph. Go ahead and copy this. We'll do it up to there. So copy that down first. Intercept solution points right here. So we have a definition here that an intercept is a solution point that has either the 0 on the x coordinates. So we can either have this case where the y value, okay, is defined and this is 0, okay, or it's backwards. So we have that the x value is defined and the y coordinate is 0. So if one of these two are 0, it's considered an intercept because it means it crosses the graph at either the x-axis or the y-axis. So here below are some possibilities that you might have. And again, I'm going to move this up just a little bit. Hopefully you can see all of this. Okay, so go ahead and copy these down first. And these are just some of the possibilities that you might have. So if you have a graph that looks kind of like this, maybe it keeps going up that way, you do have a y-intercept, but you don't have any x-intercepts. Okay, so it might never cross the x-axis. You might have something that looks like this, which is a more of a cubic type of function, x to the third power. And in this one, you can see that the y-intercept, there's one of them, okay, it's right there, but this one also actually crosses the x-axis 3 times, so 1, 2, 3. So 3 x-intercepts, 3 solutions. This one is not even a function, but it is a relation, meaning that we had some points, we put them together, and now this is what we came up with. So we do have 2 y-intercepts because it crosses 2 times, and that in itself shows us that it fails the vertical line test. But that aside, 2 y-intercepts, and it still has 1 x-intercept. And then we have the case where there's nothing at all. This is a circle, and even though it's not a function, we can make circles using 2 different functions. We can do the top half and we can do the bottom half and put them together, okay? And we'll see a little bit of that in a few more examples. Okay, so go ahead and write these down. Next, we have how to find these intercepts. So we're going to go ahead and do this algebraically. So as always, copy it down first. To find x-intercepts, we're going to let y equal to 0 and solve for x. And to find y-intercepts, we do the opposite. So we let x equal to 0 and solve for y. It almost seems counterintuitive, but the reason it works is because if you're crossing the x-axis, well, y is always equal to 0 there. And if you're crossing the y-axis, x is always equal to 0 there. Okay? So let's look at this example. It says identify the x and y intercepts of the graph of y equals x cubed minus 4x. So I'm going to go ahead and move this down just a little bit so we can see how this works. So for the x-intercept, okay, we're going to set y equal to 0 and solve. So I'm going to copy my equation, y equals x cubed minus 4x. And instead of the y, I'm going to put a 0 there. So 0 equals x cubed minus 4x. Okay. Now, some of you might not remember this next part, so please pay close attention. If you have more questions about it, reach out to me, let me know. Here, what we're going to do is factor. Okay, so we are going to factor using GCF first. GCF stands for greatest common factor. Okay, so both of these have at least one x in common, which means I can divide an x out of here and an x out of here. If I divide that x out, I'm left with x squared minus 4. Okay, so it's kind of like you took an x out from this term and from this term, and we're left with this. Okay, then from here, you're going to set equal to 0 because that's what we're solving, each of them. So set equal to 0 each and solve. Okay, so that means I'm going to have this one's going to be x equal to 0. And that one, once we're at this point, we're kind of done. So there's one answer. Okay, this one is a little bit more difficult. So x squared minus 4 equals 0. So we could do this 2 ways. I'm going to go ahead and show you how to do it with the factoring method because we do a lot of factoring. So we're going to go ahead and factor this right here. So here, I know my work's kind of all over the place right now, but this right here, we're going to factor trinomials. Okay, so, sorry, binomials, not trinomials. So we're going to have 2 parentheses, an x in both parentheses, and we need to figure out what 2 numbers are going to go in here that if multiplied will give me that -4, and if added will give me the middle term of 0. So in case you don't remember this is kind of going back to that ax squared plus bx plus c that you saw earlier. And when you try to factor a trinomial like this, okay? Um, Usually you have an x and an x, and then plus or minus some number here, plus or minus some number here, so that when you foil this thing, you end up with this again. So hopefully you kind of remember this. If not, if I need to do an extra lesson on this, just let me know and I can do a review lesson on this. Okay. But as it turns out, this one is going to be positive 2 and negative 2 because 2 times negative 2 is going to give me that negative 4. And if I add 2x and negative 2x, it gives me 0, which gives us that middle term right here. And that's why you don't see any middle term here. Okay. So from here, we set each of these equal to 0 and we solve. So minus 2 on this side gives me x equals negative 2. This one I add 2, so x equals, you can't see what I'm doing, positive 2. So this one has 3 x-intercepts. Okay, it has x equals 0, x equals negative 2, and x equals 2. Okay, we're going to go ahead and find the y-intercept now. That one will be well, quite a bit faster actually. So now we're going to find the y-intercept. And to do that, we set the opposite equal to 0. So we're going to set x equal to 0 now. Okay, so again, here's my equation. Y equals x cubed minus 4x. I'm going to plug in 0 into all my x's. So y equals 0 cubed minus 4 times 0. And this one comes out nicely because 0 cubed is just 0. 4 times 0 is just 0. So therefore, y is just equal to 0. Okay, and that is our one y-intercept. This is a function, so it's only going to have one y-intercept. If it had two, it would fail the vertical line test, and therefore it wouldn't be a function. Okay, so last but not least, we're going to do a sketch of this. So I'm going to do that at the way bottom. I'm going to use everything that I have so far. So something along these lines. I have at 0, I have a point. I have an x-intercept. Okay. I also have an x-intercept at negative 2, and I have an x-intercept at positive 2. And I have a y-intercept at 0. So what could this graph look like? Well, I mean, it's not going to be a parabola because if it was a parabola, it would skip this one entirely. So this is where your parent functions come into play. And again, we are going to see those a little bit later, but just as a recap, this function here, okay, this one right here, it's a cubic function. This is kind of review, okay, from algebra 2. So it's cubic because of this little 3 right here. And the cubic function, the parent for the cubic function is y equals x to the third power, x cubed. And this graph looks like that. Okay. Once you start adding to it, okay, so let's say you have ax cubed plus bx squared plus cx plus d. Okay, this is like the longer form of cubic functions. Once you start adding stuff to it, this right here kind of gets like pulled. So it starts to look kind of like this. Okay. And if I make it negative, well, it flips. So if I were to make this negative, it would be the other way. But anyway, we'll get into more of that later. But with this information, we can do a pretty good sketch of this one. Since it is positive, okay, I can say that my graph might look something like that. Okay. And this is a decent sketch of y equals x cubed minus 4x. Okay. All right. I think that's it for this part of the video. Yes. So this video is going to actually be a little have two parts to it. So this is the end of part 1 for section 1.2.